Now we are going to do question number 4 of Mechanics Time 1, January 2021. The question is, a metal grider AB has weight W newtons and length 6 meters. The grider rests in horizontal position on two supports C and D, where AC is equal to dB and is given as 1. When a force of magnitude 900 Newton is applied vertically upwards to the grider at A, the grider is about to tilt about D. When a force of magnitude 1500 Newton is applied vertically upwards to the grider at B, the grider is about to tilt about C. The grider is modeled as non-uniform rod whose center of mass is a distance x meters from A. Find the value of x. So what we need to do to solve this question, first of all, we need to understand there are two conditions given. The first condition is, this is the first case, this is the second case given here. First case is when a force of magnitude 900 Newton is applied at A. I mean, if we apply a force of 900 Newton at this point A, so the grider will tilt about this point D. And if a force of 1500 Newton is applied at B, then the grider will tilt about the point C. And this is a non-uniform rod. Non-uniform rod means its center of mass will not act in the middle. So we have to find the distance where the center of mass will act. We have to find the value. So what we need to do is to solve this one. First of all, let's draw the force diagram, and then we can use the moments to solve this question. So let's say here I have. So what I need to do is, first of all, I will complete the force diagram. In the first case, what I have to do is, let's see, the force of 900 Newton is applied upward here. This is a 900 Newton force. And the distance of the center of mass, let's suppose center of mass is the point where the whole mass of the rod will act. If it has a mass m, or I can say it, let's suppose I can take, let's see if any information about the mass of the rod is given. Yes, the weight of the rod is given W newtons. So I will take the weight of the rod. Let's suppose it's acting at a distance of, this is W newton acting at a distance of x meter from, this distance from this one is x meter. So now there are reactions at point D and point C because the rod is in contact with point D and point C. So reaction at point C will be, let's say it is RC, and the reaction force acting at point D, let's suppose, is RD. Now in the first case, when this force of 900 Newton, because we are considering the first case, when the force of 900 Newton is acting at A, so this rod will lift from point C, so it will not be in contact with this one. So the reaction RC will be 0 in this case, and it will tilt about this point D. So basically how we will do this question, we will make two equations, and then after solving this equation, we will get the value of x. So first I will take the moment about D. I'll say taking moment about D. Okay, when I will take the moment about D, so I need the distance of every force from the point D. So for that, what we will do, let's say this force W is from D. The total length of the rod is 6 meters, and W is at a distance of x meter from here. 1 meter is on this side. So this total from here till here, if I will count total, it is, the remaining is 5 meters. From this 5 meter, if we take this x, so this remaining from here till this one will be, from total 5, we are taking x away. So 5 minus x will be this one. And so if I am taking about D, so obviously this RD will become 0 because it's passing through this one. So then what it will be, this W will provide a clockwise moment, as sorry, this 900 will provide a clockwise moment, and this W will provide an anti-clockwise moment in this case, because we are lifting it up, so it will try to rotate it in this direction, in the anti-clockwise direction. So using a anti-clockwise moment is equal to clockwise moment, we will get, if I will take, let's suppose, a clockwise moment, but the clockwise moment and anti-clockwise moment both should be equal. So as about RC is already zero when we apply the force of 900 Newton, so no need to consider this one. This force of 900 Newton is at a distance of 5 meters from RD. So I will say it 900 into 5, and then because of W it will be equal to, I will take it W into 5 minus X. That will become, if I will calculate 900 5, I will get 4500. So 4500 is equal to W into 5 minus X. Let's say this is equation number 1. Now once again I will take the second case, second situation. In the second situation, what I need to do, I will redraw the force diagram, because it's better, it will take less space to redraw the force diagram. So let's redraw the force diagram. Okay, now the force of 1500 Newton, as per question, if you see, the force of 1500 Newton is applied at D, so then the grider is about to tilt at C. So let's first complete the force diagram in this case. W is already X. W is at a distance of X meters from this one. Reaction RC, sorry, at D is RD, and at C is RC. Now this time force of 1500 Newton is applied here, so it will lift from here, so RD will be equal to 0. Then it will tilt about this one, so we will get and I will take now the moment about R point C. So taking moment about C, first I need the distances of each point from C. So if I will take this is one of the forces here, this 1500 Newton is acting here. The distance of 1500, because this is 1, so if I will take, it will be 5 meters. The distance of this W, this total is X, and from here to here, if I will take, if I will consider from this is 1 and this is X. So if I have to take from this one, that we can find easily about this distance. So as this is X, from X if I will take away 1, so this remaining one from here till here, it will be X minus 1. So now once again I will take the moment about, taking moment about C. Now if I will take the moment about C, already RD is 0 because the force of 1500 Newton is applied here, so it will lift it up. So if I will take the moment about C, now I have to consider which force will provide the clockwise and which force will provide the anti-clockwise. Now, as this force is applied upwards, so it will provide an anti-clockwise moment, and this W will try to provide an opposite moment about it. So clockwise and anti-clockwise, if I will make equal, so W time, it will be W time X minus 1 will be equal to 1500 times 5, because the distance of this force from this one is 5 meters. So now let's calculate this. 1500 times 5, I'll get 7500. So W into X minus 1 is equal to 7500 Newton. This is our second equation. Now first equation we add here already, W into 5 minus X, that was W into 5 minus X equal to 4500. No, I will solve them simultaneously. And for solving simultaneously, what can I do? I can take the value of W from here and put in this one. So if I will take W from 1, W will become 4500 over 5 minus X. I can put it in equation number 2. If I'll put in equation number 2, so I will get X minus 1 into 4500 over 5 minus X, and that is equal to 7500. So let's solve them now. It will become 4500x minus 4500 and shift it to the other side. So will be 7500 times 5 minus x. Calculating this one will give me 4500x minus 4500 equal to 7500 multiplied with 5. I'll get 37500 minus 7500 x. Shift it to that side. 4500x plus 7500x will be equal to 37500 plus 4500. So now add in this one 4500 also. So this side will become 42,000 and add 4500 with 7500. I'll have 12,000x. So finally x will be equal to 42,000 over 12,000. So I'll get divided by 1000, 12,000. So we'll get 3.5 meters. So x will be equal to 3.5 meters. That is a complete answer of this question.